This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com.
You don't have people on the platform up above or having to, bring your materials up. Your workers are on the ground much safer than being up above.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, please follow us on Twitter. You can find us there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with our hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. Those ratings really do help promote the show, help more and more of our friends in the industry hear about the show, and then join in on these important conversations. On today's show, our guest is Bill Fucich. Bill is a senior sales engineer for Volkmann, a manufacturer of high-performance pneumatic vacuum conveyors. We recently saw an article in the trade press about their line of enclosed pneumatic conveyors, which are used to transfer powders, pellets, and other bulk materials without the risk of contamination. And so we invited Bill into our forum to learn more about that application of fluid power and about the pneumatic system that makes it possible. So, Bill, welcome to Fluid Power Forum.
Well, hello, Eric. Hey, thank you for this opportunity to allow Volkmann to be introduced to your audience and your followers.
Well, we're glad to do it. I'm always excited to talk about applications of fluid power. One of our goals is to showcase all of the different places that fluid power is used. And we've certainly not discussed pneumatic conveyors on the show before. So we're happy to have you on board. Bill, tell us a little bit more about yourself, if you can. What's your background? How did you find your way into this business?
Well, actually, I have an engineering degree. I graduated from Penn State in 1976, so I'm getting up there in years. And I've through my career, I've been involved in fluid handling, also gas handling, the sale of pollution control equipment, and then I found myself into powder handling, so all the mediums, liquid gas and solids. I had the opportunity to join Volkmann actually in 2008. Volkmann is a privately owned company based in Germany, and the decision was to open a U.S. office in 2008. I worked as a representative, and then had the opportunity to become a full-time employee in 2011. Yeah, I was actually employee number 3, and we've grown through the years now, and we've moved, and just the sales have been tremendous growth. In fact, we now in the U.S. operation have 11 people. Okay.
Well, yeah, that's. I always ask people that come on the show what their first exposure to fluid power was. Was that something you learned at Penn State? Was that part of your curriculum there, or when did you first come to it?
Not actually. I mean, my degree at Penn State is actually environmental, but you touch on some of those core basic courses in the beginning. By virtue of working with Volkmann, the fluid powder end of this is the vacuum generator that's used to transfer the powders. Yeah. So it became kind of a work in progress, if you will.
So it was when you came to Volkmann is when you first got exposed.
Yes.
Well, as you know, it's a versatile technology that can be used in a lot of spaces. Tell us more about Volkmann as a company. We know you make conveyors. What else, if anything, does Volkmann make, and what markets is it in?
Yes, well, Volkmann, again, they're a German manufacturer.
Uh-huh.
They're based in Soest, Germany, which is in the western part, maybe about 80 miles northeast of Cologne. And our core business are the vacuum conveyors. We have two lines. One is a VS, which is kind of our workhorse conveyors. The other is a PPC, which is a pharmaceutical pneumatic conveyor. And then there are associated equipment that we would have to complement the core units, the conveyors themselves. So, on the pickup side of the device, there's hoppers and things that we're doing that just complement the vacuum transfer of the powders and bulk solids.
Yeah.
Volkmann, we serve many industries. We're involved in the food, pharmaceutical, chemical, nutraceutical. Most recently, in the last, I'd say 5 or 6 years, tremendous success in the additive manufacturing industry, and that is the transfer of the powdered metals.
Oh, wow.
Yeah, and the transfer of those metals actually stems. Volkmann was established in the late 70s as a vacuum conveyor manufacturer, and again, they're a family-owned business. And from the very get-go, due to the vacuum pump itself, it's a compressed air-driven vacuum pump.
Yeah.
We were able to move powders with bulk densities, 200, 300, 400 pounds a cubic foot.
Mm-hmm.
And we then, by working with the powdered metal manufacturers from the very get-go, it was just a natural for us to get into the additive manufacturing. Yeah. And that's the 3D printers, for printing metal parts.
So you're actually moving the powdered media that is deposited and becomes the additive manufactured part? Is that the place that your technology sits?
Yes, we sit exactly. So the raw powder, which is transferred to, say, the inlet hopper of the 3D printer,
right,
we're making that transfer. And then there's other areas around the 3D printer. So after the part is made, and that's called a build box,
right,
excess powder is vacuumed. We vacuum that from there, and we go to a screener to reclaim the powder. And so there's that transfer, returning to the inlet or maybe to a storage hopper. So we're moving the metal powders all around the printer. Wow. There's also at the bottom of the printer where excess powders fall. We'll pull those to reclaim.
Yeah.
It's very interesting, and it's just because our vacuum pump is so efficient. It works on a Venturi principle,
right?
And so there's a series of nozzles. It's not a single Venturi, but depending on the pump, it's either 3 or 4 nozzles. And by expanding the compressed air through this series of nozzles, it's an additive effect. A single Venturi will generate maybe about 13 inches of mercury,
yeah, where
our vacuum pumps are capable of generating up to, say, 26 inches of mercury. And of course, now that allows us to move these powders.
Yeah. Well, I had not heard of that application before. I first, as I mentioned in the opening, I saw an article in the trade press that was focused on pet food, if I remember correctly. Yes. And I think that's part of the packaging process, if I can call it that, where you're filling bags of pet food, right?
Yes, exactly. In all these various industries, that's a very typical one. Mm-hmm. In, say, the pet food or in the food, or, the sweeteners, your little yellow, pink, white packets right, at the restaurant. We work with many of those companies to fill those sachets.
Yeah.
Okay. So we're involved in the packaging end and any steps in the manufacturing. We may pick up the powder, take it to a mill to mill it, grind it. And then from that mill, it needs to be sized. So we may pick up from there and then over to a screener.
Right.
So wherever the powder needs to be moved in the process, that's where you'll find Volkmann in that transfer.
It sounds like it's a lot of different environments then, essentially, in terms of where this technology, you can find it, right? It really depends on the medium that you're trying to move, it sounds like.
Yeah, and then just to give you an extreme, so we talked a little bit about powdered metals and, the stainless powders, iron powders, tantalum powders, copper powders. That's the heavy end.
Yeah.
And then where Volkmann also fits, if you or your audience knows about fumed silica, now we're down to fumed silica could be as low as 2-3 pounds a cubic foot. I like to think of it as conveying smoke. Okay, and so we convey both extremes, and basically we're Volkmann. We run to the difficult applications rather than running away. You're not going to find us like in something, I'm going to say it's relatively easy application, say plastic pellets.
Yeah.
There's no dust. We want to go to those difficult, dusty applications, and that's due to one of our advantages is in the filters that we use.
Yeah.
The standard filter that we use in probably, I'm going to say 95% of our applications is rated for 0.3 micron.
Wow. Well, and that's a nice segue. I was going to ask about, challenges in the environments that your machines operate in. It sounds like, as you just said, your sweet spot is in the most challenging applications, it sounds like. So can you give us a sense of what are some of the hazards that you need to avoid in those applications? Dusty, well, I heard you say dusty. Are there other environmental concerns that affect the performance of this technology?
Yeah, definitely. What is always important in powder handling, I mentioned before I was involved, say, in selling of pumps and valves for liquids. And those laws, viscosity, what you're doing, okay? It's easy to transfer pumping water to pumping other media, okay, liquid media.
Mm-hmm.
Powder handling is a tremendous challenge due to, as you're saying, these environmental issues that actually more extend to the physical characteristics of the powder itself. Therefore, that's a challenge. And so what's always very necessary for us to do is test, literally try to duplicate in our lab the conditions. And when I say the conditions, primarily the distance, the conveying distances,
right,
both the vertical and horizontal component. And the challenge then becomes the physical characteristics of the powder. Is it going to absorb moisture? Is it cohesive? How does it flow? So generally speaking, though, if we can pick it up, either picking up from a hopper or with a wand, we'll be able to move it. Mm-hmm. And so the challenge is really identifying these physical characteristics, doing a test if we can, and just so that our customers and ourselves have much comfort in that, number one, we can convey the powder, and number two, assure that we can transfer the pounds per hour that's necessary. Right. Their transfer rate, right, or kgs an hour.
We'll continue with our guest in just a moment, but first, let me tell you more about IFPE, the International Fluid Power Exposition. IFPE is the place where you'll learn everything you need to help your company stay on the forefront of the mega trends affecting your business and industry. From sensor technology and data analytics to robotics and automation, you'll see the latest innovations in fluid power that will help your machines and applications achieve your technology, performance, and business goals. Only at IFPE can you have in-depth technical conversations with other engineers and executives to spark new ideas, or talk with suppliers about your specific challenges and the solutions they offer, or find new suppliers and new ways of doing things, or attend innovative education classes and sessions covering the latest fluid power topics and industry trends. No other trade show brings as many sectors of the fluid power, power transmission, and motion controls industry together in one place. And this event happens only once every 3 years. in conjunction with ConExpo ConAg, the largest international gathering place for the construction industries. Our next IFPE show will be March of 2023 in Las Vegas, Nevada. To learn more and reserve your place, visit ifpe.com. So, Bill, I'm hoping we can talk about why pneumatics is the right choice. I mean, you've done a good job describing kind of what it is you're trying to achieve and what some of the challenges in the environment are. Remind us again, what role is pneumatics playing in this, and why are you going to that technology for this?
There's a couple primary advantages with vacuum conveyors.
Right.
Again, we're taking compressed air, expanding and generating a vacuum. Actually, you're generating suction air. It's much like your shop vac in your garage, or your sweeper. There, of course, it's an electric motor that is generating that vacuum, but it's that suction air that it's the velocity of that air that picks up the powder and moves it from the pickup point to the discharge point. And so it is enclosed. And then if you can imagine, one of the great benefits is many people, and it's still happening, is let's say you have your ingredients and you're making cake mix, okay, to be packaged. So you got your sugars, your salts, everything, your cutting bags, dumping it into a blender. And much like your kitchen, if you dumped a bag of flour into your bowl, you create a dust cloud.
Right.
So with vacuum conveying, that housekeeping goes away because it's all enclosed. It's neat and clean. The other thing is ergonomic issues. Now we're able to do everything at floor level. We have our ingredients or the powders that we want to transfer down below. You don't have people on the platform up above or having to, bring your materials up. So your workers are on the ground much safer than being up above. We have a toolless design, and by that I mean you're able to again disassemble our receiver that sits at the destination end. The receiver is, if you imagine, a cylindrical vessel. It has the discharge, the bottom of it. It has a valve, a discharge valve, and then in the upper part is a filter package, if you will, filter cartridges, and the vacuum pump on the cover above. So the way these things operate is you generate that vacuum, pull material into the receiver, the cylinder, discharge valve is closed, material accumulates inside, and the simplest way is on timing. The vacuum pump is turned off, the discharge valve opens, and the material is just a gravity dump into that blender, okay?
Right.
And the valve shuts, the vacuum pump comes on, so we pull in and convey.
Right.
But the beauty of ours is you can take our unit apart. Tools are not required. You can disassemble one of our receiver literally in minutes.
Okay.
And if cleaning's a premium, it's very easy to clean the units.
So is it traditionally a human being at that reception end that's controlling when the material is brought in, or is that an automated function?
No.
Yeah.
We would provide a controller and one or the other. I'm glad you mentioned that point because we can provide our basic unit totally pneumatic. Okay, we would use a pneumatic controller. So in these environments, say even a class 1 or class 2 environments, we're intrinsically safe. One of the beauties of a Volkmann conveyor is there's no rotating parts. So the only source of energy, source is the the static charge associated with conveying powders, and that's the only ignition source. We don't generate heat. No rotating parts. So we're an intrinsically safe unit, even with our controller. So inside that controller, it's controlling all those functions, turning the vacuum pump on and off, opening and closing the discharge valve, sometimes we have a vibrator to aid in discharge of the powder out of our receiver. So all those functions, that cycling, is controlled by that device.
Yeah. And that can be tuned or set to a variety of different settings, depending on how much material, how quickly you need it, or how does that work?
Yes, essentially in its basic form, okay, it's all done with pneumatic timers.
Mm-hmm.
So it's just, you're controlling suction time, and I'm talking seconds here. Say a typical suction time is maybe 5, 7, 10, 12 seconds. Discharge times would be, 3 to 5 seconds. And then one will ask, but what about those filters? And then with every one of these cycles, we're cleaning the filter. We have a charge of compressed gas, or, sometimes we get involved in inert conveying, but that charge is expands under the cover of the receiver and then cleans the filters. So on every cycle, we're cleaning. That's why we talk about continuously conveying, but we're doing it, pull in and dump, pull in and dump.
Yeah.
And within every one of those cycles, it's necessary to clean the filter.
And so I'm sorry, I'm not, the filter itself is filtering the powder that's coming through?
Well, when you pick up when we pick up, so we're picking up either from a hopper or maybe just wanding out of a bag or a drum.
Right.
So those filters then separate, you're pulling powder and air into the receiver. And so the filter now separates, because you have to keep the powder in the receiver, okay,
right,
and allow it to accumulate. And then through the filters, that air that's picked up with the powder is exhausted with the expanded compressed air that's generating the vacuum, okay?
So it's a filter that keeps the material and gets rid of the air, right?
Yeah.
Did I hear that right?
Yeah, we need to keep the material in the cylinder,
right,
to discharge.
Oh,
yes.
That's what you want, right? That's how the system is designed to work. It's just normally filters filter out impurities from fluid, if you will. But it sounds like this is the opposite. So
yeah, in this case, the impurity is the product.
Right, exactly. Yeah. Exactly. That's great. Well, it sounds like an innovative approach to this, especially that enclosed nature. That's unique to the Volkmann product, or are there other enclosed conveyors?
This design vacuum conveyor, there's nothing there unique, but where we shine, if you will, is some of the mechanical conveyors. There's vibratory feeders, volumetric feeders, belt conveyors, bucket elevators. Many of those technologies, they can be enclosed, but they are open and may be subject to contaminating a product.
Right.
And the other thing, those technologies are very difficult to clean. Okay, it's a problem where you're needing to clean between batches, and that's why our units are really prized in the that cleaning aspect is key, especially in the food, pharma, and nutraceutical markets.
Yeah, it's absolutely key. As you said, you need to have your product and nothing else in those bags at the end of the line.
Yeah, and then again, the cleaning between batches.
Yeah.
You can imagine some allergens, and cleaning is prized. Each company has their own, cleaning procedures. We just design our equipment so that you can break it down to every powder contact part can be broken down into its each component, so that you're able to very readily, clean it,
right,
and then reassemble, again, done in minutes.
Yeah. Well, that's great. It sounds like a fascinating application of that technology. That it sounds to me like it really depends on that vacuum pump as like the main component to the whole process. It's what makes things move inside the system.
That's what makes it move.
Yeah.
Yes.
That's
and exactly. Our trade name for the vacuum pump is, it's a multi-jector, and that is the key component to, keep things, keep the powder moving, if you will.
I'm curious what you guys see as kind of the future of this technology. Are there any innovations coming in this space that people should be watching for, or what's next?
Yeah, well, we touched on it briefly, but that powdered metal and the 3D printing, additive manufacturing, okay, is that actually got us through these recent years, with COVID and industry and the difficulties. We were able to maintain our sales goals in that particular industry. Where Volkmann, not so much in the vacuum pump design, that Venturi principles there, but any innovation for us is we're doing a lot on the pickup side of things. Okay. In other words, equipment just to make the pickup of powders easier.
Right.
Okay. And also we're always looking at improving the filtration, our filters, I know there's some things behind the scene that we're working on. And so any of our innovation is going to come in the associated equipment, to transfer the powders.
Right. Well, that's great. We'll be looking forward to some of those advancements. And as we said earlier, it really is a technology that you're going to find in a lot of different markets, doing a lot of different tasks through this fairly simple but a well-engineered technique.
Yes.
Right. All right. Well, hey, Bill, that's going to wrap things up for this episode of Fluid Power Forum. My thanks again to Bill Fucich, who has been my guest on this episode. If you'd like to connect with him, learn more about their products and about Volkmann, we're going to put contact information for Bill and for the company in the show notes, and you'll be able to contact him through that mechanism. Remember to learn more about fluid power. Your best bet is to attend IFPE, the International Fluid Power Exposition. And there you can see firsthand the latest fluid power technology advancements and learn from industry experts. That next show is coming up in March of 23 in Las Vegas. For more information, visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, reminding you to join us next time in the forum.